Hello everyone, welcome to the CIS 166 Chapter 10 lecture. Chapter 10 deals with exceptions, Section 1, the try and catch block, and Section 10.2 deals with throwing exceptions. So in this video, I just want to focus on 10.1 first, which is the try and catch blocks, and then we'll deal with throwing in the next video. So um, an exception is an object in Java, just like everything else, right? A string is an object, everything else is an object. An object is an object, right? So, an exception is an object that is generated as the result of an error or an expected event. We've been dealing with this a lot, actually, even though you might not have paid attention. I'll show you an example in a second, but it's pretty much, let's say there is a number. I'm asking the user to provide a number and I provide text, right? So if that's the case, then we're gonna get some type of exception that will be thrown. It's your responsibility as a programmer to detect and to handle that exception. And if we don't handle the exceptions, this will just crash the program. Um, an exception handler is going to be the section of the code that gracefully responds to these exceptions. So we want to create these exception handlers, and that process of intercepting the exception and responding to them is called exception handling. The default exception handler deals with anything that you have not handled and will print an error message, usually in red, and will crash the program. That's bad. Programs crashing is very bad. So let me show you an example of this in action. So I'm just going to create a new Java file called exception examples or exception example, and I'll leave the default for everything, and I'll create a new Java project called exception example. The same. Oh, sorry, cancel. I'm gonna create inside the project. I'm gonna create a new class called exception example. Exception example, and I'm create a main because I want everything to be in this main. And let's create a very simple example that asks the user to enter a number and display the number to the user. All right, I want to keep it very simple over here. So we're gonna need two things. We're gonna need the number, and to get that input from the user, we're gonna need a scanner keyboard in this case. Now, notice scanner is red. That's because we have to import java.util.scanner, right? So now we can use the scanner. Notice that I'm not initializing the scanner yet because something could go wrong with it. So I don't want to I just want to declare it. I'll initialize it later. So in this case, let's ask the user for a number. So now we can initialize our keyboard. Uh, Keyboard equals new scanner, and then we're taking it from the keyboard, so we're gonna use system.in. So that's one. And then we're gonna display a message by using system.out, which represents your screen, and we're just gonna do print. Um, Enter a number. That's all we want to ask. With a space to let the user, place that number next to the message. Then we want to set the number equal to the keyboard dot next int because it's a number that we're retrieving, so we use next int. If it was text, we would take next line instead, right? And then display the number back to the user. So simply we're gonna say system.out.println because I want to print a line, and inside of this we're just gonna say thanks for entering the number and then plus the number, and then plus, maybe we want to end it with exclamation point. So we'll do that. Thanks for entering the number, and then the number the user entered. All right. And that's how really our program is gonna do. So if I run our program, notice that it's asking us to enter a number. Let's enter the number, for example, 25. Notice I press enter and it says thanks for entering the number 25. That's how we expect our program to run. The problem is that we have to account for all of the things that could go wrong in this program. And that can take a little bit of time. Um, but you've been through a many programming classes at this point, and you might have seen a lot of errors. So those errors now, we have to start thinking back to them. So for example, one might ask, enter a number, and I might want to type 25. Ooh, the program crashes. Okay, now in here in the console, it's fine. It's just gonna crash it like this. But imagine you playing a video game, something that's graphical, right? If something like this happens, your program is going to freeze and crash entirely, and then the user will have error messages appearing, and it might freeze their computer. You don't know what's going to happen when that program crashes. So it's very important for us to handle those exceptions. So this is the default exception handler. The default exception handler crashes the program and displays the whole message of what's going on with this. Now we can see the type of exception by reading right here the first line. Exception in thread main, meaning the main function. Java.util.input mismatch exception. This is telling me what type of exception we are receiving. In this case, input mismatch. Because I try to enter a text instead of an integer, which is the expected input. And then, this is the stack that traces the error back. So it starts with this, and then if we follow this stack, we see all the functions that we're trying to actually do something with this input that we provided. All right, so this is the stack, and we're kind of tracing this stack over here. So we have to handle this exception. Now, before we handle it, let me just show you this diagram. This diagram illustrates how exceptions exist. So remember that last class in chapter 9, we were talking about how objects objects is a class inside of Java. Now every object we create um, automatically is inherited from object class. So throwable is an object. Throwable inherits the characteristics of an object. Um, Exception is a throwable. So all of this is part of this throwable class. All of this is inheriting. So notice how intricate the inheritance can be. A file not found exception, for example, is an IO exception. An IO exception is an exception which is a throwable, which is an object. So we can get very deep into this inheritance tree. It's important for us to note that throwable contains two things, errors and exceptions. We want to handle all exceptions that we can throughout our program. So the exceptions could be an IO exception, such as we can't find the file, or the file ended, but people were trying to retrieving data from that file, or it could be something that happens at runtime. For example, a division by zero, which is an arithmetic mistake, or something like just happened with us, right? That we put the wrong input type. So all of that can crash the program. An error is a lot more critical than an exception. We do not want to handle errors, okay? To deal with errors, we have to use other strategies. An error would be something like memory running out, or for example, the internal error with the Java virtual machine. A lot of time these errors are beyond our control, so we don't want to handle them. We want to maybe, rewrite our code so it doesn't run out of memory, or sometimes it's the problem with the person's computer. So we can only try to, use algorithms to make our programs faster and using less memory, but we can't really just handle it. For handling, we're going to make sure that we do that for exceptions. Now, if you're interested, I'm going to share this link with you, this link right here, programming guide Java, list of Java exceptions. This has a list of every exception that exists in Java. Um, and actually errors as well. So within this, we can see stuff like arithmetic exception, which is a runtime error, uh, no pointer exception, class not found exception, etc. So there's a lot of exceptions we can get. Uh, Notice I'm scrolling through this. There are so many. All right, and as you see them, as you find them in your programs, and you see these errors, you can go back to this reference or the documentation and just kind of look at it. So for example, file not found exception signals that an attempt to open the file denoted by the path name has failed. So it kind of tells you what that exception is. I mean, we could have guessed that what's file not a found exception does, but if you need more information, you can always come back to this documentation. So anyway, so once we know there is an exception we need to handle, how can we handle this? There's a few different approaches, but section 1 focuses on this try and catch block. In a try and catch block, we're going to put all of the code inside, all of the code that an error could occur inside of the try. Then we're going to use a catch in order to catch the exception and tell the program what to do in case that exception occurs. Um, a try block is going to contain one or more statements that can potentially throw an exception, and the application will not halt if the try block throws an exception. Instead of halting, instead of crashing, we're going to go to the catch clause and deal with the exception that it caught. All right, so I'll get back to this in a second. But let's go back to the example. So in this case, this is the code that could cause an error right here. Declaring the variables doesn't really cause any errors, so we can do that outside of the try and catch block. But asking the user for input and displaying the message could cause a few errors. For example, the Java util input mismatch. Notice that if I write a try, there is an error message saying that I have to insert something else to complete this. So for now, we're going to do a catch. Now a catch requires two things as denoted on the PowerPoint. A catch requires an exception type and a parameter name. The exception type is the name of the exception class you're trying to handle, and the parameter name is the variable which will reference that exception object that you just caught. It's kind of like a temporary variable. So in this case, we're trying to handle the input mismatch exception. So that's what we're going to type here. Input mismatch exception. Now notice there, and then I'm gonna put E for the variable because that's the exception we're catching. Notice it's gonna give me an error. It's gonna say, hey, we can't resolve this to a type. That's because I have to import that exception class. So that's going to be in java.util dot input mismatch exception. Notice the auto completes for me. So now it's fine. It's going to catch it. So now what I can do is when this happens, I can do a system.out.print ln and I can say error. Um, the entered input was not a number, for example, and semicolon over here. So now instead of seeing this very ugly message, when we run this and we type, for example, 5, error, the entered input was not a number, right? So it shows our message instead. Okay, which is better. It didn't actually crash the program. If there was code outside system.out.print, let's say end of program, and let's run this again. Enter number 5. Notice it gave me the error. The entered input was not a number, but it also went to the next line of code to end the program. So the code keeps going, it doesn't crash. Whereas if I didn't have the try and catch exception, it would actually crash the whole thing and we would never see this line of code. So it's important to do this. Now, there are other errors that we might see. For example, if I don't put system.in, maybe I put something else, system.inner, and I try to run this, notice that that's going to also give me an error. Um, exception in thread main, unresolved compilation problem. Well, this is because it's a compilation problem. Uh, but in this case, uh, that would be the wrong parameter basically that we are being given. So I could try to deal with this as well by catching another error. So for example, I could try to catch a illegal argument exception as well. Now notice that the E is a local variable to that catch block, so I can use E again somewhere else. So system.out.println error, uh, your argument is not valid, for example. Silly, but illustrate this. So let's see if it would run. I don't think it would. Oh, there we go. It did. Let's say 5 again. And the entered input is not a number. But if, again, let's try this. I don't think it's gonna run because, uh, proceed. It doesn't, in this case, the program is not running, so it doesn't catch this. But if the program was to run, it would say, maybe there's an illegal argument over here. Um, yeah, it won't do it because these are compilation problems, not program problems. But I hope you get the idea that I can catch different mistakes that my program might cause during the runtime. Another thing I can do is create a finally clause. Now, the finally will run regardless if an error was caught or if an error was not caught. So, for example, I could have system.out.print and say thank you for using our program. I'll do a println actually. So thanks for using our program. And then I can run this. So let's say I put a right input like 25. Thanks for entering the number 25. So it runs the try. Then there is no errors. So it goes to the finally and it does that. Thank you for using our program in this case. Once that's done, it continues on with the rest of the program. If there is an error, again, let's say I type that, it's going to catch that error. So catch entering the entered input is not a number, and it's going to run the finally. Finally, it will do system.out and display that message, and then continue with the program. So the finally should be created most of the times for something that you want to do if the user either gets the right thing, on the try, if everything runs smoothly, and if once you catch that exception, you want to see it as well. Um, so that's the idea in there. Um, Now, of course, the program is still ending. Maybe I want to put this in a do while. So I could put this whole code in a do while, for example, and I could create a new variable um, called a boolean maybe um, that asks if the number is valid, for example. Now this boolean is just gonna be true or false. So is valid right now, let's just say that this is true. We just assume that the number is valid. So as long as it goes through this, if it arrives here in this part of the code, we're just gonna say that is valid equal true to let the user, because it ran the whole try block. So this is the last line, which means valid is true. But if there is any type of errors, we're gonna say is valid equals false. And so any of the catches we'll have is valid equals false. So what that allows me to do is that I can run this program uh, while is valid is true. So while is valid, I'm sorry, I'm gonna run this loop while it's not valid. So not is valid, right? So while not is valid, I'm going to keep running this. But I don't want to say thanks for using our program every time, right? So I could put an if statement over here. Oops, I'm missing a parenthesis. No, I'm not. Oh, that was the parenthesis right there. So this closes the finally, this closes the while. So do while. There we go. Now it's fixed. I'm sorry. All right. So if is valid, we can say print, that. Otherwise, um, we can say else. We can say something like please provide a number instead. Something like that. Um, so if I run this again, this improves a lot. So let's say I type 5, it's going to say error. The entered input was not a number. Please provide a number instead. Why? Because it's going to try to do this. As soon as there is an error over here, it's going to catch that input mismatch and it's going to display the message error. The input is not a number. It's going to set valid to false, then it's going to go to finally. And finally, if it's valid, which it's not because it just set false, then it displays this message. Please provide a number instead. Then it asks the user to provide the number again because the while loop runs as long as it's not valid. So once it becomes valid, like 5, then it stops. It says, thanks for entering number 5. Thank you for using our program. In fact, these could technically be all the way down here, but then there's other problems. What if, this concatenation doesn't happen? So I might want to catch that exception as well. All right, so that's how the try, catch, and finally block works, and we can improve it by creating this while loop. All right. Oh yeah, one more thing. We can actually retrieve the message, the error message that is inside of this variable e. And in order to do this, now I'm just gonna change. I'm gonna say error plus e. Now e is an object, so we can, for example, get message. So if I get message, it will retrieve the error message that actually occurred. So let's type 5. Ooh, in this case, it's saying, please, it's saying no. Uh, Interesting. It should have a message in there. Let's try one more time and let's type 5. So in this case, it's no, there is nothing inside of E. Um, but if there was, then get message would retrieve whatever it was thrown by that object. In this case, it's no, even though there should be a message in there. I'm not sure why it's from, why it's not displaying anything. Um, hmm, I'll have to check into that, guys. But usually we can get this message to display as well. I don't know why it's not showing here. All right. Well, that pretty much concludes what the try, catch, and finally uh, do. Okay, so I'll end this here, and then I'll do section 2 really quick, and hopefully you'll be able to use this to improve your programs. All right.